Oh, hey, good morning. Lesson is for my honors integrated 1 class. This is going to be for section 24.1. I have to watch my step. I got my big dog in the middle of the floor. She's not moving. But before I start, I hope everyone's doing okay out there. We've got a pretty, I think, good lesson today. It's going to use a lot of the tools that we've built in the last couple sections, and I'd like to show you how we're going to start tying concepts together in this section. So today's goals, we actually have 3 goals, and we're going to accomplish, more than 3. But the first 2 goals, I think, really will simple, and then we'll see how we've used previous concepts to create properties of a 4-sided shape. So let's go ahead and jump in. Our very first goal is going to be to find a parallelogram. Our second goal is going to be review congruent angles created by parallel lines and angle side angle. And our third goal is going to be to use corresponding parts of congruent triangles or congruent to create properties of parallelograms. So again, I think this is a pretty good lesson. We see a lot of concepts tied together here. So I'll start off with our first goal, and it's going to be to define a parallelogram. And a parallelogram is a 4-sided shape, which I didn't write down. It's a four-sided shape where both sets of opposite sides are parallel. So here's an example of a parallelogram. Remember this mark and this mark, these arrows are telling me that this side is parallel to this side. These 2 arrow marks and these 2 arrow marks are telling me that these sides are parallel. And I've written it out. I said side AB is parallel to side DC, as well as side BC is parallel to side AD. So a parallelogram is a 4-sided shape where both sets of opposite sides are parallel. So I'm going to check off goal number 1. Now, actually, before I continue, let me make sure everything is in the screen, and it barely is. A parallelogram, before I go any further, has a symbol. So I can write the word parallelogram, or I can just draw the following symbol, and that's me talking about a parallelogram. So if I was to name this thing, I would say parallelogram A, B, C, D. And you could have started this anywhere, but I started from the top left and went in a counterclockwise or positive direction. So this symbol right here means parallelogram. So parallelogram ABC. D, and I know that the opposite sides, both sets of opposite sides are parallel. So I've finished my first goal. Our second goal here is going to be review congruent angles created by parallel lines. Alright, so in a previous video I called these corresponding angles. They're not corresponding angles, they are alternate interior angles of parallel lines. And alternate interior angles of parallel lines must be congruent. Okay? And I wanted to point this out because this shape that I have here, I can actually build a parallelogram out of it. Okay, so again, alternate interior angles are congruent. All right, so let's see here. Let's kind of get rid of this here for a second. So we know that angle 1 is the same as angle 2. Okay, now if I was to take a line and draw it out and in this direction, and do the same thing over here and then draw it in this direction, and if I drew them in such a way that I knew that this was parallel to that and this was parallel to that, I actually now have another set of alternate interior angles. I have this guy right here and this guy right here. These are alternate interior angles. Let me just erase everything else so you can see it here. These are alternate interior angles for another set of parallel lines. And we know that these guys are going to be congruent. Right? So let me point out the fact here that we're actually going to have a couple sets of congruent alternate interior angles. So I have, back to my original drawing, where I knew that this side was parallel to this side, and this angle 1 and this angle 2, those guys were alternate interior angles. And let me just kind of erase everything else. Okay. So here I actually have a four-sided shape that's actually a parallelogram, and if I draw a segment that connects one vertex to its opposite vertex, a diagonal, I actually create two pairs of congruent angles. And not only that, I have a congruent side because of the reflexive property. And so what this means is I've actually created two identical triangles. So if I want to create identical triangles in a parallelogram, I literally just have to connect opposite vertices. And I know that this angle is alternate interior to this angle, right? And I know that this angle is alternate interior to this angle. The double marked are alternate interior for the vertically oriented lines. The single arc are alternate interior for the horizontal, right? And then again, I have that side. So very quickly, we can determine that we have congruent triangles by angle, side, right? So we actually have this congruence pattern here, our angle, side congruence pattern. Let me use my words. All right, so we're almost done with the lesson, right? So again, we're tying together a bunch of old ideas here. So let's just kind of outline an argument about, you know, our properties. Okay, let's see here. I'm gonna tie all this together. Okay, so alternate interior angles of parallel lines are congruent. We get that twice when we make a diagonal, and then we get congruent triangles by angle, side, angle. All right. So let's start off with a parallelogram. J, K, L, M. JK, no, seriously, is parallel to ML, and JM is parallel to KL. All right, so I have my parallelogram, right? We just saw that if I draw a diagonal, I get two pairs of congruent alternate interior angles. And not only that, I also get congruent side by a reflexive property. So very quickly we can say that, and I'll just name one triangle, so JML. So we went from the arc with 2 to none to 1. So we're going to go to the arc with 2. So JML is congruent to L. M has no arc, so that's K. And then that goes to J, which has the 1, which matches up with that L. All right. So very quickly, I know that I have this. All right. So I've argued that my triangles are congruent by angle, side, angle, and now I'm into the corresponding parts of congruent triangles are congruent. Right. So we're gonna use this now. Let's look at this here. So we're actually gonna say three properties here. Okay. The first property is that I'm going to be able to claim or argue that opposite sides of parallelograms are congruent. So that's the very first thing we're going to see. Remember, that's our symbol for parallelograms, so opposite sides of parallelograms are congruent. And this is going to be true because of corresponding parts of congruent triangles. So remember, JM, the first two letters is going to be the same as the first two letters as the other triangle, LK. So I know that JM is congruent to LK. And this is true because they're corresponding parts of this of congruent triangles, right? I also know that ML, which is this side of my parallelogram, or my last two letters of the triangle, is in the same position as KJ, right? So I can then say that ML is congruent to KJ. Right, so this is one of the three properties. So if I have a parallelogram, I know the opposite sides are going to be congruent. The second thing I can argue is I can argue that the opposite angles are congruent of a parallelogram. Right? So angle M, which is my second angle in the triangle, is going to be the same as angle K. Right? And again, this is because corresponding parts of congruent triangles are congruent. Honestly, we could do the same argument, draw the diagonal going this way, and then very quickly have the same realization of J and L. Or we could realize that these two angles are the same as these two angles, and when I add these two angles together, that must equal what these two angles together, and then we can then conclude that angle J must be also the same as angle L. Okay. So we've just seen that opposite angles are also congruent because of what's it called? Because of corresponding parts of congruent triangles are congruent. I got one more thing I want to show. Last thing. Again, this is called a diagonal. And the diagonals of a parallelogram actually bisect each other. Diagonals. I gotta tell you who's bisecting. Diagonals bisect each other. Remember, bisect means to cut in half. Okay. So to reach this conclusion, it's actually pretty simple to do. What we would do is we would actually need to add the second diagonal, right? And you can actually, let me erase this guy. Alright, so what we could actually do in this one, what we could actually do is we could very simply reason that this angle must be the same as this angle because these are alternate interior angles of parallel sides. We know that JK, no seriously, is congruent to ML, right? Yeah, right there. So what we actually have here is we're not only going to have a parallel side, but we have congruent sides. So this little triangle, we'll call this little triangle J and K. That's going to be congruent to triangle. Let's see. So J had the one, so L and M. L, M. All right. And so what that means is that JN is congruent to. I made a mistake. I made a mistake right here. This is why the order matters. 1, none, 2. Right? 1, none, 2. 1, none, 2. So this would be LN and not LM. LN, M. So we know that JN is congruent to LN. Alright, so JN, this guy, is congruent to LN, this guy. So if these guys are the same length, that means that they got cut in half. That means that JL got cut in half, right? First two letters, first two letters. And then I could also say that NK is congruent to NM. Right? So that means that this NK is congruent to NM. And that has to be true because these guys are corresponding parts of congruent triangles. So since this is the same as this, that means that this whole thing was also bisected. So that's how we would get to the point where we would argue that diagonals are bisected. So I'd like to just draw a bubble diagram just to help us see what our potential first steps are when we have a parallelogram. So I'm going to check the last goal. And let me just do this here real quick. All right. So if I know that I have a parallelogram. Okay, you know, we actually know some things, right? So we know that we have opposite sides are parallel. Well, I guess that's that's included in the picture, so I don't know how to edit that out, so you just have to go through. We know that we're going to get opposite sides are going to be congruent. So we have a parallelogram. That means that I know that I must have this happening in my shape. That's one potential first step to these problems. If I have a parallelogram, I also know that I have opposite angles that are also congruent, right? So if I have a parallelogram, that means that I know that I have this happening in my shape right here. So my opposite angles must be the same, and these opposite angles must be the same. I didn't draw that very well. I'm sorry. I'm not left-handed. Oh, this is beating me. All right, there we go. So that's another avenue for a first step. Again, also I have a parallelogram. We saw that the diagonals bisect each other, right? And so let me see how much space I have before I draw this in here. I'll draw it up here. So this is kind of a alright, so here's my parallelogram, and then that means that this diagonal will cut that diagonal in half. And this is how I show that. These marks are showing me that my diagonals have bisected each other. And a little line to connect it. Alright, so starting off with a parallelogram, this is a clue. This is it gives us 3 directions to go for a possible second step, right? Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. Alright. So, again, I hope you guys are all doing it right. Thursday's getting up. Oh, she's bumping into things. So I will post the next video on Thursday. Again, I hope everyone's doing okay out there. And let's keep doing our work and doing what we need to do. And we can all get credit and move on to the next class next year. Again, I hope everyone has a good day. Have a good day. Oh, watch out Thursday.